So in this one, we're gonna talk about theorem 7 and 7, right? And also theorem 8 and theorem 8. So remember we talked about theorem 5 and also theorem 6, which the other one was about the plus triangle inequality. The other one was about the minus triangle inequality, where we said like the bigger part is always less than the small pieces added together, right? So now we're gonna talk about what about when small pieces are actually minus together. We're gonna talk about when small pieces are actually minused together, right? Small pieces when they are minus together, it's actually what happens is the opposite, right? So absolute value of x minus absolute value of y, it must be less than the bigger part minus together, right? Which is absolute value of x minus y, right? And also the smaller pieces minus together is less than the bigger part plus together, right? So in order to memorize these, theorem 5 and theorem 6, it speaks about how if we add the smaller pieces, when they're added together, they're always greater than or equals to the bigger part, right? It doesn't matter if the bigger part are added together or they are subtracting each other, right? And also in theorem 7 and 8, it says that when we minus the smaller part, the smaller pieces, when the smaller piece, absolute value of the smaller pieces are actually minus together, they're always less than or equals to the bigger part. The bigger part here is actually bigger, which kind of like makes sense, right? So this is what's happening with theorem 7 and actually theorem 8, right? So there's this conclusion: x to the value of x minus absolute value of y is less than or equals to x plus y, right? And then absolute value of x minus absolute value of y is also less than or equals to x minus y, which this one is the bigger part and this one is the smaller part subtracted in pieces, right? So now here we're going to be speaking about theorem 7 and 8, right? So now theorem 7, we remember we talked about theorem 5 and 6. Last chapter we talked about theorem 5 and 6, right? So now in theorem 7, we talked about this big part, these smaller pieces that are added together. These smaller pieces that are actually added together are always greater than or equals to a smaller pieces, right? That's what we talked in theorem 5 and 6, right? So in theorem 8, we're gonna talk what happens when now the smaller part pieces are actually subtracted, right? That they are added, they are subtracted, they are less than the bigger piece, right? That's what theorem said, right? So theorem 5, it said that the absolute value of x plus the absolute value of y is greater or less than is greater than or equals to x plus y, right? Another case is that x, absolute value of x plus absolute value of y is also greater or equals to x minus y, right? That's always the case for theorem what? For theorem 5 and 6, right? So in 8, it's now x, absolute value of x minus absolute value of y is actually less than or equals to the bigger part, which is x plus y, right? And again, that's with x, absolute value of x minus absolute value of y is less than or equals to x minus y, right? So that's always the case. So remember, in order to memorize this, you need to know about the bigger part and the smaller piece and the smaller part, right? The bigger part or the smaller part, right? When the smaller pieces are added together, they're always greater than the bigger part, right? And then when the smaller part are added together and minus together, they're always smaller than the bigger part, right? This is a kind of like our mnemonic